my screen?
Yeah, sorry, let me do that.
Thank you.
You should be able to do it now.
Great, thank you. Let me find the right one. Cool. Okay, well, I'll make a start and then we can share around. So I guess last week we started to talk quite a bit about the importance of mortality data, and we had some really good talks about the system, where your mortality data came from and how it was put together, and how we could use that information to consider the way that we can be analysing mortality data. And we finish off the session by starting to have a look at some different measurements of mortality frequency. And specifically, we really looked at that crude mortality rate. So we'll just do a little recap of the crude mortality rate, and then we'll go through a few other measures of mortality frequency. And I guess just to reiterate that the importance of the mortality rate is to help give an indicator of what deaths look like within a defined population during a specified time interval. And it really does provide that starting point for examining the health of a population and how it compares globally, how different groups within that population can compare. So we started off by looking at the absolute numbers of deaths. We realised that they had some benefits in that it gives an exact amount. It's able to provide some useful information for health systems by knowing how many people they're treating, but we really can't measure the impact that mortality could be having on a population, and especially when those populations really differ in age groups, in sex ratio and things like that. So we had to start moving towards looking at that mortality rate. We had some examples from Pacific Island countries where there's higher numbers of deaths in Fiji. That doesn't necessarily imply that it has a greater issue with mortality than somewhere like Niue, because their population sizes are very, very different. So then we went through the crude mortality rate, and that was our really simple rate where what we did was we took the number of deaths, we divided them by the estimated resident population. That resident population is always the midpoint of that year. That's thought to be the best indicator of the average population for that entire year, and is often calculated by taking the information from January 1st and December 31st and getting an average, and then we multiply it by 1,000. And to get our rate. Now, because there's lots and lots of small numbers of deaths in the Pacific and for different groups, that sometimes we might need to combine quite a few years to get a more robust numerator and a more robust rate. So if we're to do that, this is when we come back to this rate, where we take the number of deaths for the whole 5-year period, we divide them by 5. Then we would take the midpoint for that 5-year period. So if it was 2013 to 2017, we would take 2015, it's right in the middle, and we multiply it by 1,000. So in this example, over the 5 years, we had 250 deaths, just over 15,000 people living in the population. So that's an average annual death rate of 3.2. But we did get to the point where we started talking about the crude death rate being very heavily influenced by the population structure, and that it can't be directly compared. So populations with many, many more older people will have a higher death rate, because at some point mortality is inevitable, and then that will influence the rate. And because of that and those different age structures, we can't directly compare the two population groups. So population grids can be a really useful way of understanding how your own population is proportioned, and having a good understanding of that is just a really useful exercise, because it will help you to understand what type of rate you should use, and also what other countries you could compare your populations to if you had a crude death rate. So we've got different ones here where there's many more older people, and this one is the more traditional population that we used to see much more, where there's many more younger people, and then they get very, very small towards the end. So before going on, I wondered, so I know we've just got Alison and Peonia on the call at the moment, but I wondered if you could just share a little bit of information about the types of deaths you would get questioned about, and just anecdotally what types of deaths you hear in the news in your countries, and what types of questions that the government would be really wanting information on, because we'll come back to that at the very end and have a think about, as we go through different types of mortality rates, which rate could be the best to use in different situations. And so to give an example, in Australia, people are very interested in suicides of younger people and understanding if that rate's changing over time. So we spend a lot of time thinking about that, and we also spend a lot of time thinking about our infant death rate and measuring improvements there. So they're two really key things that we look at a lot for Australia. So are people just happy to share a few different things that they get asked about or that you hear about, and then we will come back to that at the end?
Okay, so maybe I can start. So with Palau, yes, suicide is a big thing. We just had another teen suicide, and it was the story about that was published in the paper, and people were making a call about how the community should pull together about what kind of policy changes should be made, so that interagencies discuss the matter and find out better ways of dealing with the issue. Another one is NCD related deaths. We have a lot of medical referral patients that go off island, so we have issues with diabetes and other medical issues. And I guess what the government is looking into is what kind of services can they provide, or what kind of information can they give the public to have a healthier lifestyle, so that money is not spent with people being medically referred off island. If they can change that to more public health awareness, then we wouldn't have so many people. We wouldn't be spending the bulk of the money sending people off island. We have those kind of issues, and then of course we have cancer-related deaths, and that's just something we can't, I guess, fix. But it relates to tobacco, the use of tobacco, and all those kind of programs. So
yes, you're fitting into that NCD space as well. That's really interesting. Thank you for sharing that, Alison. And interesting to always hear how many similar issues are going on across countries. Diabetes is a big focus area here too, especially with those issuing of services in some of the more remote communities.
Yes. Thank you.
Thank you. Is anybody else happy to just talk through a few things that are often in the news or that they're hearing about in relation to specific deaths for their countries? Even in the chat is fine as well.
I think, Pony, you had your hand up. Please go ahead. Hi.
Yeah. Hi. Talofa, can you hear me?
Yep, we can hear you.
Yeah, I think it's some most experiences that are similar with other Pacific Islands in terms of I think there are some factors that hinders the process of registration, registering the deaths, especially when I think in Samoa we also have a high rate of fatal death from car incidents and also for example, the committing suicides and some other incidents that really depends on the special operation to declare the cause of death. So it's also a policy issue because in terms of our work, when we have death at morgue waiting for operation to declare the cause of death, so we cannot register those deaths unless we get the coroner. Because that's those specific deaths are under the investigation, and then there are some other parties that involve, for example, the police, the Ministry of Health, and the Ministry of Justice and Courts Administration. So unless we receive a coroner report, official report from the doctor after the special operation, then we are mandated to register those deaths. But there are times that the families need to take that deceased to burial and all that. But it's just because we have policies in place, and sometimes we have to use our common sense because to ease out how to do our work. And one of the difficulties we encounter between our close collaboration with the Ministry of Health in terms of death registration is the coding, because at the moment I think we hardly, to be honest, and we hardly have the cause of death coded. Since I started here as the registrar, I haven't seen any causes of death coded by the Ministry of Health and by us. In fact, that we don't have that expertise of coding the causes of death, and I'm pretty sure that the Ministry of Health, because the doctors only declare the cause of death and blah blah blah, but the medical records officers are responsible to code. But I know for sure that we in Samoa we need more training on coding to upskill our. Because even us, although that we are only mandated to register, but we do need to understand the coding as well, because we are obligated to do the reporting side of things.
Yeah, and it sounds like they're very sensitive issues as well that you're getting queries on. So once again, sitting in that injury space with the car accidents and the suicides, and looking at things. So at the end, when we're coming back through, we can talk through maybe a couple of factors in how you can get some indicators out there that might help answer some of the questions without some of the coded cause of death information, because that is particularly tricky. But we'll go through all the rates. But thank you for sharing that from Samoa's point of view. Interesting, suicide has come up again. It is such a sensitive issue. So we've also got RMI and Vanuatu on the line. Are you happy to share just a couple of various things that you would get asked questions on, either from government or different types of deaths that you're hearing about? And then at the end, we can just really consider which type of mortality frequency rate could be best used to measure those. And definitely in the chat is fine as well. Well, I'll keep going on, but if anybody wants to add anything in, and then when we come back to it, please feel very free to speak up. But we've got some good information there. So we'll start off with age-specific mortality rates. So age-specific mortality rates is the number of deaths per 1,000 for people within a given age group, and very much like a crude death rate, it's within a given time period as well. So these types of rates are really useful when we're interested in a particular age. So maternal deaths, for example, we would have a look at ages of childbearing women as our denominator. Anything that affects children, we may just look at the number of children. There's also some deaths that are more likely to happen in older people, so we may just be interested in looking at a very small bracket of somebody's age to get some information around that age. And they're also really useful for helping us to understand how old people are when they die and where some of our highest age-specific death rates are as well. So the formula for an age-specific death rate is very similar to that of the crude death rate. So we have as our numerator at the top here, deaths. So this example, we're looking at deaths in 25 to 29-year-olds. So we would put the number of deaths in 25 to 29-year-olds in 2020. And then for our denominator, population for 20 to 20 olds in 2020. So really important that we remember to change that denominator to our age group of interest as well. So down here then we multiply by 1,000 to get our final rate. So when we graph age-specific mortality, the typical pattern is a J shape. So when I say a J shape, we typically see very, very high mortality, well, not very high, I shouldn't say that. It's typically higher mortality in infants, and then it starts coming down as we see much lower mortality in children and teenagers, and then starts to gradually go up as for younger women may die in childbirth. Younger men are more at risk of dying due to accidents and other risk-taking behaviours. And then as we get to 35, mortality then has a trajectory that goes up. So here's a really typical J-shaped graph when we're looking at age-specific mortality. So we can see here that the infants is a bit higher, then it goes down, then it starts to go up again. So when we're graphing, we need to be really careful with the scales that we're using. So there can be quite fine differences in the rates. And if we group everything too low, so you can see on this graph, everything just appears that it's pretty much 0 with the rate. But really, if we change the scale of it, we start to see some of those finer differences. So for example, it's important to know that in the 1 to 4-year-olds that rate is slightly higher than the 5 to 9-year-olds, and we are seeing some increases in mortality in those ages from 15 to 19 up, and they could be linked to things such as injury and risk-taking behaviours, like I was saying before. So the way that we graph things is really important to make sure that we're checking to make sure that our data looks like it makes sense. So it's quite rare for mortality to deviate from this type of norm. So if it's not looking like the typical J shape, we'd start wondering what was going on, whether there's some data quality issues, but also just to watch that scale to make sure that we are looking at some of those fine changes, because some of those age groups are very important age groups for indicators of health, and we may need to make sure that we're getting health interventions in the right spots. And so we can do a logarithmic graph to get past some of the issues with scales. So generally in a graph that we see that the scales on the side equal intervals, but when we're seeing really wide-ranging factors, we can change that scale around to pick up some of those finer changes in the mortality rates. So I believe that I'm going to hand over now to Euless, who's going to give us an example of how to graph a logarithmic graph in Excel. So I'll just stop sharing and then hand over.
Thank you, Lauren. Can you see my screen?
Yeah, we can see your screen now.
Okay, great. Yeah, so I will show you through how to make a logarithmic scale for your graphs in Excel. So I've got here some age-specific mortality rates data, so once you have your data, you do what you would normally do with to graph in Excel. You would do in this case a line chart. But as Lauren was saying, when we do a simple line chart like this with a normal scale, the differences, especially between 1 and till 40, we can't see any difference. It's just a flat curve because the later part of the curve is much higher, so those differences just disappear. But there's still some information that you can get from the differences in those rates. So it's important that you use the proper scale. So to change the scale, you can either double click on the scale itself where the numbers appear, or otherwise you can go up. If you're in the chart, you can go up in format, and you should find the option here to get to, in this case, the vertical axis. And once you're there, you see on the right popping up some different options on how to customize your axis. And in this case, we want to go to the one called axis option, which is 3 bars next to each other. And it's in the first of those parts in axis option. There's axis options. And if you scroll down, you should see at the bottom there's simply an option to set the axis as a logarithmic scale. And if we do that, so normally it should put the proper base by default. And you can see here that the chart looks quite different now, and we see the J shape that we expect to see in most of the data. And so doing the logarithmic scale helps really plotting the difference for the smaller values that we have in the graph. And in this case, we can see, as Lauren was saying, that the death rate between 1 and 4 is slightly higher than 5 and 9, and then 5 to 14 is quite similar. Then in this case, for example, we can see that there's it suddenly increases for males from 15 to 19, and so it's plotting this difference is really helpful to see some of the finer trends that we can hope to see from the computation of the mortality rates. So that's why it's important. And then after, from about 30, we see that the line is pretty much linear, which means that the mortality rate increases exponentially because it's a logarithmic scale. So yeah, so that's that was simply it's how to make a logarithmic scale on the Excel graph. I don't know if any of you have any question. Otherwise, I think I can hand it over to you, Lauren. No, okay. So a question from Samoa. Do you want to speak up or do you want to write your
Yeah, I just want to know that because it's a bit obviously it's a bit difficult to, as I mentioned before, to join the training and save the public because I may miss some of the important steps that you have mentioned earlier. But I just want to know that if there are any like steps by steps of doing this charge that we need to revisit after our work. Because
I
it's
can, yeah.
yeah,
I can
because obviously it's
put
a
it in
very
the,
good way of presentation and easy analysis to look at the charts, the graph. But for example, at the moment, I look at the table, the Excel table, and the charts, but I just need to realize to know the steps of getting to the chart.
yeah, yeah. Then I can put that in the presentation. I'll add some slides so that there's a step by step with some screenshots so that you can refer to that later if you need to reproduce it. I'll add that.
Yeah, thank you very much. So I think that's what we, especially in our case, some of us are attending the course and also trying to serve the clients coming in the office. But it's better to have those screenshots and steps for reference afterwards, please.
Yeah, yeah, of course. I understand that. Okay. Yeah, so if there's no other question, I think we'll go on with the presentation.
Great, thank you. I will go back to my presentation. Can you see my screen again?
Yeah.
Great. Okay, so now that we've covered off the age-specific mortality rates, we'll move to the age-standardised rates, and they're very, very reliant on age-specific rates. So it's a nice segue into it. So as we've mentioned a few times now, that the age structure of the population can really affect our mortality indicators, because we may just accidentally be highlighting that one population has an older cohort in it than some other populations. So to compare between populations appropriately, what we can do is we can take our age-specific mortality rates and apply them to a standardised population. So what we're doing is we're modelling our current age-specific rates on a population that both of them would be the same, so we can compare against. Sorry, is someone able to mute, because I'm just hearing myself twice? So I'm just going to take you through an example of how population distributions can differ a lot, even in the one country as well. And I just have an Australian example here. So one of our really key policy questions in Australia is to reduce the inequalities faced by our Aboriginal and Torres Strait Islander population, and really to provide life outcomes that are equal to all Australians. So mortality rates are a very key indicator to reaching this goal. So we have a look at life expectancy, we have a look at major causes of death and decreasing preventable causes such as suicide. We have a look at infant death rates, and we provide a lot of this indicator information to measure some of the changes over time. But if we were just to look at and compare the crude death rates for Aboriginal and Torres Strait Islander people and compare them to non-Indigenous Australians, it wouldn't quite look right. So for our Aboriginal and Torres Strait Islander people, the crude death rate is 4.6 deaths for every 1,000 population. And for non-Indigenous Australians, it's 6.7 for every 1,000. But let's just have a look at the population. So what I've done here is in these columns, this is the proportion of the population that's within this age group. So you can see for our Aboriginal and Torres Strait Islander people in Australia that it's a much younger population. So over 11% of the population are in the 0 to 4 age group, and over 11% as well in the 5 to 9 age group. But for non-Indigenous people, it's 6%, and stays very much at that 6% and starts to increase. And then when we have a look at the older age groups, it's quite different again. So we've got 7.2% in people over 75 for the non-Indigenous population, and 1.3 for Aboriginal and Torres Strait Islander people. So when we're seeing this rate here of 6.7, we're really just reflecting this higher proportion in the older age groups. So we need to standardise them. So this is our formula, and it's a little blurry, I'm sorry, but basically what it's saying is the standardised rate equals the sum of RI multiplied by PI divided by the sum of PI. So what does that actually mean? So RI is the age group specific death rate for each age group in the population being studied, and P is the population of the age group in the standard population. So to standardise our population, we would apply the age group percentage listed under the world average. And for purposes when you're putting your tables together, you're going to use the WHO World Standard Population Distribution, which looks a little different again. It's got a bit over 8% in those younger age groups, and it gets a little bit lower as we get to the older age groups. But I want to take you through an example. So you will have a resource that I'll show you after this that is a template where basically you just need to paste the data in and it populates for you. But I'm just using a template that we use at the ABS first, just to demonstrate the age-specific death rate on its own. I'll just make that a little bigger so you can, actually that's too big. Hopefully you can see that a bit better now. So what we do is, firstly, we want to calculate our age-specific death rate, and we really want them in 5-year bands. So if it gets much bigger than 10-year bands, then the rate is really very, very volatile. These are heavily modelled numbers, so we want to keep them, if we can, to our 5-year bands. So we put the number of deaths in each 5-year band. And you can see that we've done that for our Aboriginal and Torres Strait Islander population here, and for our non-Indigenous population here. Then we have our population figures also in the 5-year band, so they're along here. And the next step is to create our our age-specific death rates. Now I'll make those a tiny bit bigger so we can see them. So you can see that for our Aboriginal and Torres Strait Islander population, in the 0 to 4 age group, there's an age-specific death rate of 1.6. And for our non-Indigenous population, an age-specific death rate of 0.7 for the 0 to 4. And over here are our crude death rates that we had before. We've got 4.6 for the total, 6.7. Now we've got a standard population. So for this one, I haven't used the world population. I've just used an old Australian population from a previous census. So picking your standard population can be a bit of a task within itself. But as I mentioned before, when you produce your figures, you'll actually use the world standard population. But we've got this here. And then when we go to select our standardized death rate, what we do is we multiply the age-specific death rate for the 0 to 4 age group by the 0 to 4 age group of the standard population. And we would do that for both our Aboriginal and Torres Strait Islander population and our non-Indigenous population. And we do that across all age groups. So we multiply them, then we sum them up. So remember, in our formula, we had to sum them. And then we divide them by the standard population, so by the total standard population here. And what it gives us is the total of all of our age-specific death rates against a population that looks the same for both of these populations, which had very differing age groups. And we can see that our age standardised death rates look quite different to our crude death rates. So for our Aboriginal and Torres Strait Islander population, we now have 9.4 as our age standardised death rate. And for our non-Indigenous population, we now have 5.4. So there's still some inequalities in mortality that we're seeing when we enable that comparison that we weren't seeing when they were just crude death rates due to those different age structures. So it's a really, really important tool that we've got here. And I'll just quickly see if I can show you. Okay, and this is the one that you'll be using. So basically all you have to do is you paste in your deaths, you'll paste in your population numbers. You can see here that the world population is already in here. And then in the calculation page, the same things are here. So I think it's right over here. We've got our rates over here. And then you go to the results. So when you do your tutorials, you'll be taken through how to do that. But I took you through the other example just because there's a little bit more happening in this spreadsheet, but everything is in here. And you can see that we have the directly age standardized rates here. So it's the same formula that's being applied. So it's called a direct age standardization technique, which means that we're directly applying our age specific death rates through to a standard population for different things that we'd like to compare. And so it's a really, really important tool that we use all the time in mortality. So there are a few principles that we need to consider when we use age standardization. So our denominator, so that remember that's our population size, should never be less than 30. And it seems unlikely that for all deaths that we would ever have a denominator less than 30, but sometimes when we're looking at very specific age groups or causes of death, we can get very tiny populations of interest. So if it's less than 30, age standardization isn't the right tool for it. We should try and keep our numerators at least 20 deaths. You can, in some circumstances, go to 10 deaths, but we tend to get a bit too much standard error if we go too low than that, because it is a modelled output. So to get past that, we tend to combine years. So we've already spoken about combining 5 years of data to create more robust data sets, and that can also happen in your age standardization. Age-specific rates should, if we can, be calculated on those 5-year age bands. If you feel that there's too much volatility in those or too many zero values, you can go to the 10-year age bands. But the 20-year age bands are really too broad. They're just, once again, adding too much standard error into a fairly modelled rate already. So age standardized rates, should also not be used in isolation. So if you're presenting an age standardized rate, also put next to it the counts of deaths, ratios, age-specific death rates. So really just to give it as much context as possible so people know what type of information they're consuming. And if you're really interested in something that's related to a specific group, so infants, for example, then use an age-specific death rate. So really think about what you're trying to measure and what you're trying to show. And we'll go back through a couple of examples later on for that. So this does lead us very nicely into infant mortality and under 5 mortality, which are very, very important indicators for population health, maternal health, how a nation can be going, and is linked quite closely to some life expectancy indicators as well. So we do have these down as indicators under the Sustainable Development Goals, and really under that good health and well-being. So we have by 2030 to reduce neonatal mortality to at least 12 per 1,000 live births and under 5 mortality to at least 25 per 1,000 live births. And many of the causes in these age groups are fairly amenable to intervention. They're quite preventable with good health care. And so it is an important indicator to be putting out there and measuring. And I just wanted to show you this because infant mortality is linked quite closely to, I don't know what that is, sorry, to life expectancy. So this is a graph that we produced in Australia, and you can see here that at the bottom what we've got is we've got the years 1890 to 2015, and the 0 means that this is the proportion of improved life expectancy gained by 0-year-olds. So you can see that from 1890 for males and females, that by improving health in infants, Australians gain a lot in their life expectancy. But as time goes on and the infant mortality rate keeps going down, we're tending to gain less from from the 0-year-olds, and now we gain more from our 65-year-olds. So the other half of the graph is how much life expectancy we gain from those aged over 65. So now in the last 20 years, we tend to gain more life expectancy by improving health and well-being of things like NCDs. But when we had very high infant mortality rates, it was intrinsically linked to better life expectancy outcomes. So it can be a really important indicator to measure just how changes are happening within your country around rates and how they linked to healthy life expectancy as well. So how do we actually measure infant and child mortality? So infant mortality is looking at people who have died who are under the age of 1 year, but there's a few indicators that sit within that. So we've obviously got the early life trajectory here. So conception obviously occurs. Now check within your countries. A lot of countries have a different scope of what a neonatal and gestation would look like. But internationally, when you get to 28 weeks of gestation, it's considered then that if you were born and had a live birth at that point, that it would be considered that you were an early neonatal death. Before this, if you haven't taken a breath, it would be considered a miscarriage and would be in different outputs. But from 28 weeks, we're starting to count the gestation. And so as soon as a live birth has occurred, and we have early neonatal deaths that go to 1 week after birth, and within the first month, we consider that a neonatal death. So if it's in between 1 week and 4 weeks after birth, then that's considered a late neonatal death. And the reason that we're interested in that first month of mortality, as well as the full year of mortality, is that these first 4 weeks, and this first week in particular, are really our highest risk for mortality. And that's where we really like to have a look at the different causes and things and the way that the mother is interacting with the health system to see if there's different interventions that can be put in place there. And obviously from 1 to 5 years is where we have our under 5 mortality, and we consider that whole period from there. So then we would have the neonatal mortality rate. So to answer our sustainable development goal, we would have to provide this as a measurement. So once again, considering our denominators and our numerators. So for our numerator, we are interested in the number of deaths in infants aged less than 28 days. And then we would divide this by the number of live births in that same time period. So the number of live births is our denominator. So I know that you've been working on your birth data, and that figure is going to go in here. And then the same thing, we multiply it by 1,000 to get our neonatal mortality rate. Now, if you are interested in the early neonatal deaths and the later neonatal deaths, then you can divide them up into early neonates and late neonates. Sometimes your numbers may be too small and you may not be able to do that, and sometimes there's not enough information there. So just consider what works best for you, but doing the full 28 days is completely acceptable and gives a very good indicator of maternal and newborn health and access to care. So as infant mortality rates fall over time, what we generally have seen internationally is that we have improvements in deaths due to infectious diseases and other environmental influences, and then a greater number of deaths would still remain for things such as congenital conditions. So some of the major causes of infant mortality sit in here. So for those neonatal periods, so remember that's the first month, it is things such as birth complications and can be very much related to some issues that the mother may have had during childbirth or with her access to care. We can see those infectious diseases and malnutrition, but as I mentioned, the congenital conditions, and they could be things such as chromosomal disorders, such as Down syndrome, or it could be some other things such as hemorrhaging related to birth that we might see. Prematurity is also very commonly seen. And so things like underdeveloped lungs we could see in that period. Once the babies reach 1 month, we do tend to see more of the malnutrition, infectious diseases, and of course external causes such as accidents and other injuries. So it's really important to understand if your data is looking like we would expect. Now, the infant mortality rate, it's very, very similar to calculating the neonatal mortality rate. So instead of having just infants of 28 days and less in our numerator, we have all infants. So all infants aged up to 1 year old would go into our numerator, and then it's the number of live births once again, and we multiply those by 1,000. Now, because you're likely to have very small numbers for your infant mortality rates and your neonatal mortality rates, really consider aggregating those years just to give us much more robust outputs, and also report with confidence intervals. So the confidence intervals are calculated automatically in the spreadsheet that you've got, and during the tutorials, it's best to take you through them. And then really look over longer term rather than year to year. So the small numbers can produce a lot of volatility, but also mortality can take quite a long time to change. So really looking at those long-term trends can be very helpful with infant mortality. And you can see the graph that I showed you before. We started ours at 1890, so it was a very, very long period, but that's really when we're able to measure that long-term change and see some improvement. And our under 5 mortality rate, very, very similar. So once again, our numerator, all deaths in children aged under 5, and then our live births for the same time period. And we just multiply that by 1,000. And once again, it's a really important measure of development, as we are seeing a few more external causes such as injuries in those over 1 month and up to 5. They often have very preventable causes in there. So it is an important indicator to put forward. So infant and child deaths may often be underreported. So it's really good to have a look at your data and to think about this in your own local context as well. So for the early neonatal deaths, sometimes they can be missed and they can be accidentally put in the stillbirth collection instead. They can be very, very sensitive issues, and so a lot of sensitivity with around registering those deaths. So if the CRVS system is your source for this, really have a look at the processes and how you connect through with the hospital, how that information comes through, because it can be very difficult for the parents to come and register such a death like that. So have a think about the other sources that are out there as well. So the census often collects information on the number of infants. So have a look at that and see if it all makes sense, and work with the health department as well and see, are they really quite different? And also checking the proportion. So we should see a higher proportion of infant deaths that are neonatal. So if you're not seeing that, have a think about why that could be. Is it a data collection issue, or is it actually something real? Is something going on with those causes of death, and you are able to get that information out? And really doing that anecdotal check and considering, Is this what we know of the health system? Is this what we know of the health situation in our country? Is this the messaging that we're getting through? So keep questioning the information and just to make sure that it does make sense. And just before we go back to some of the examples before, so some other mortality frequency rates that you can have a look at. So just if you're doing sex-specific rates, just remember to adjust the numerators and the denominators so that you've got male, female only. So I think a very common pitfall is we may accidentally put all people into the denominator, for example, when we just need to match everything up. If you're looking at different regions where you live, just once again, adjust those numerators so it's just people living in that region. The denominator should also just be people in that region. If there's country of birth or ethnicity, the same type of thing. So just keep adjusting it. And of course, if you're looking at cause-specific mortality, you just need to adjust that numerator by the cause of interest. Now that's the end, but I just wanted to come back to a few of the examples that we had before. So we had some interesting examples where we heard that teen suicide, for example, was something that Alison mentioned she has gotten questions on, and it's a very high public health issue, and obviously something that people would want to prevent and bring those numbers down, and some of the NCD deaths. And then we also heard a few of the issues in Samoa with under-registration and not having the coded causes of death. And so for something like teen suicide, an age-specific death rate would be a really important output to go by. So really just looking at your population of interest there. If you've got the information, doing the cause-specific mortality would also be really helpful. The NCDs, once again, that needs to be the cause specific, but really consider if you've got enough information to create those age specific death rates and then standardize it. That could also be really helpful. It can be helpful to also do a sex specific breakdown of that information. Now, with something like Samoa, where you were getting a lot of queries around some of the fatal deaths, so the car accidents and the suicides, but you don't have that coded data, the all-cause information, so doing some age-specific death rates for young people could be an important indicator. So we do tend to see higher numbers of injuries in young males in particular. Young females also tend to have higher rates. So even producing age-specific death rates for that younger population and really focusing on that could provide some important indicators of what could be going on, and they could be useful things to feed back to policymakers. And if you've got information around doctor versus coroner deaths, that can also be quite helpful information, because I know from experience that coroner data flow can be very, very different as well. And so I know everybody's been very busy with their birth data, so really just the assignment is to try and just create a table of summary statistics. So we went through this table last week, so have a look at those all causes. So get your absolute raw counts in there, the counts of the infants, and then just a standardized death rate, accrued death rate, and an infant mortality rate. And over a couple of years is really helpful, so you can have a look at how things are changing. Now, did anybody have any questions? That's all I had today, but happy to take questions. Otherwise, Eunice and Chloe, happy to hand over back to you as well.
Thanks, Lauren. Nothing from me. Maybe?
Yeah, neither for me.
Sorry, I have a question. So In Palau, we have deaths that occur off island because these are medically referred patients. I know I brought this up before, but so if I were to do my charts and my tables, do I put like a separate group for the ones who died off island as compared to so basically do I do two separate tables or graphs, or I can just combine them all?
I think for Palau, you can just combine them all, but maybe in the text or the footnotes, you could just put just a note of how many people did die off island, because it does sound really important to Palau that they're in your total counts, because you mentioned they had the usual residents of Palau. Otherwise, it may look like that for people of a certain age group that you don't have many deaths, and it's also sounding, Alison, like it tends to be cancer or some other NCD treatment that's offered off island. So it could skew the results if you don't have them in.
Yes, because it's for policy making, like, for the Congress to appropriate a certain amount of money to the Ministry of Health, those kind of factors.
Yeah. So I think it makes sense then to put them in. But also, like I was saying, if you highlight for them how many people are dying who have been overseas, it's probably also very useful information for them.
Okay, thank you.
That's okay. Any other questions? Looks like we could be done. We're finished. Oh, we've got a question, sorry, in the chat. So what about those who died overseas? So this is definitely a question to consider with the scope. So for Palau, for example, people who have died overseas are in scope of their statistics. Because they generally have gone overseas for medical treatment. So they're a really important indicator as part of their data set. But we also heard from, I think it was RMI, who said that people who died overseas weren't part of their scope. So I'm sorry if I've got that wrong. So it's really important to understand why people are dying overseas, how your health department or how your registry would be capturing them if they are dying overseas, and then make that decision. So for people who die overseas in your data sets, why are they dying overseas? Are they dying overseas because they're going over there for medical treatment?
This is Kiribati, by the way.
Kiribati, cool. So maybe you need to just have a look at the scope. So I'm only talking from my experience from working in Kiribati. I think they've tended not to be included in the data set in the past, and they were registered in other countries. So they tended not to be in scope at all. So if the CRVS system is still the source of your deaths data, they're unlikely to be in there anyway, which means that you wouldn't see them to count them in. But if they're an important medical component, you can put them in and just put a paragraph in there about how many people.
Worked overseas like seafarers.
Sometimes this depends on geography as well. So if they're in international waters, or if they're in some type of water that still links to Kiribati and they haven't docked somewhere else, it can get very, very complicated. Then they can still be included in your statistics. But in general, if they've in another seat and they've docked in another country, they're likely to be counted in that other country's statistics. But maybe send some more information through just to help make the decision, just so the scope is right for your country. It's such a country-specific answer. I'm sorry, it's not black and white.
Yeah, I will come back to you and we can discuss this over by email or in a tutorial if you want this week.
Any other questions? Okay. I think we might be done for today. Thanks everyone for listening. I know it can be heavy going through the formulas, but it's a really important aspect of the mortality analysis. So please take care.
Thanks a lot,
See you later.
Laura.
Okay, bye.
Bye everyone. Have a good week.